Okay. What we're going to do in this lesson is we're going to identify the parts of a graph like x-intercept, y-intercept, minimum, maximum from just the table. Okay, we won't have an equation, we won't have a graph, we'll have just the table, and we're going to identify those parts. All right, so before you can do that, you've got to know how to identify what type of function it is. All right, so let's review that. If I have a table of, let's say, linear let's see, -2, -1, 0, 1. All right, -12, -8, -4, and 0. All right, if you look at your difference, if I take a number and subtract the number behind it, so -8 minus -12, or if you look at what they're doing to get to the next step, they're adding 4. So -8 plus 4 is -4. 0 plus, -4 plus 4 is 0. All right, so this is called the first difference, correct? All right, and it is constant, meaning it's the same thing over and over again. They're adding 4. All right, if the first difference is constant, then that means it's a linear function. All right, and so a linear function, we know that we're going to have no minimum or maximum. All right. All right. Then we can have, like if we have x and y, we got 1, 2, 3, 4, and let's say we have 6, 24, 96, and then 384. Is that right? All right, if you look at this, just looking at the table, you can tell that it's going to be exponential. All right, because if you take 6 times what is 24, so it's times 4, right? Or you could say 24 divided by what is 6, or 24 divided by 6 is 4. 96 divided by 24 is 4. So it means we're multiplying by 4 each time, right? So if you're multiplying and you're not adding or subtracting, but you're multiplying and it's constant, then it's going to be exponential. All right, and for minimum maximum, it's going to be approaching. Okay, if it's minimum, then it's going to be a growth. If it's maximum, then that's going to be decay. Okay? And we always say it's approaching, like it's approaching 0 or approaching -1. All right, so that's linear and that's exponential. So let's look at, let's say that I've got all right, let's say I've got x and y, and I've got -2, 12, -1, -1, 5, 0, 0, 1, -3, 2, -4, 3, -3. Okay, let's say that I've got this table. And if I look over to the X, it's always usually going to be +1, but just make sure. All right, so 12 to 5. What did they do to get 12 to 5? They subtracted 7. And from 5 to 0, they subtracted 5. And then we subtract 3. We subtract 1. And then we add 1. All right, so this is my first difference. So my first difference is not constant, is it? All right, so let's look and see what we're doing between -7 and -5. Well, we added 2. -5 to -3, we added 2, added 2, added 2. All right, so now this is called my second difference, and it is constant. All right, so if my second difference constant, then it's a quadratic. Okay? If your second difference is constant, it's a quadratic. So we can have, let's remember some little rules about quadratics. You're going to have a minimum if it's going up, and a maximum. And when I say it's going up, it means it's a positive quadratic. And if it's a maximum, if it's going downward, which would be a negative quadratic. Okay? Also, you can have up to 2 x-intercepts and up to 1 y-intercept. Well, now, if it was a sideways, you could have up to 2 y-intercepts as well, if it was one of the sideways, but I don't think we'll see any in here. Okay, so you're going to have a minimum or a maximum, and of x and y intercepts, you can have those too as well. An x-intercept, remember that it's a quadratic, you'll probably have 2. Okay? All right, so that's going to be your constant for second difference is a quadratic. All right, absolute value, I don't think we're going to be looking at any of those, but it will be going up and down. But these would be like +2, +2, +2, -2, -2, -2. It'd be constant, but it'd be a plus and a minus. Okay. All right, so let's look at your notes. All right, so let's look at number 3 on your notes. We have x and y, and we have -2, -12, -1, -8, 0, -4, 1, 0. Okay, over here we're adding 1. And on this side, -12, if we add 4, we get -8. -8 plus 4 is -4. -4 plus 4 is 0. So we have a first difference constant, so that means that it's linear, right? So when they ask for a maximum or a minimum, it's going to be none because it's a straight line. All right, so now we're looking at x-intercept and y-intercept. Now you only have one at the most. You can have none. All right, like if it's a horizontal or vertical line, you'd only have one intercept. All right, and what did we talk about x-intercept? Your x-intercept, that point, that coordinate or ordered pair, your y is always going to be 0. And for your y-intercept, your x is always going to be 0. Okay? Always, always, always. Okay? So you might get in the habit of doing those, and that way you can know what you're looking for. All right, so if I'm looking at this table, I already see I've got a 0, -4. So that's going to tell me that my y-intercept is -4. And then I have a 1, 0. So my x-intercept is 1, 0. Okay? Now, if my table didn't have that on there, I would have to go and look and try to find it. It would probably be the previous number or the next number, usually. Okay. All right, let's look at number 6. Okay, number 6. All right, looking at this, you've got fractions or decimals here, right? Okay, and then, oh man. All right, and then your numbers start going up pretty quick. That is a red flag that it's going to be exponential. But we want to verify it. So we know that exponential means you're going to have a constant number that you're multiplying each time. So instead of trying to deal with these fractions, I'm going to go down here to these bigger numbers. 2 times what is 4? Well, 2 times 2 is 4. And 1 times 2 is 2. And 1/2 times 2 is 1. 1/4 times 2 is 1/2. All right, so we know that it's exponential. Okay, so exponential, it's either going to be going up or it's going to be going down. Right now we don't know which one. Okay, we could possibly have an x-intercept or not. All right, so we're just going to have to look. X-intercept, for an x-intercept, your y is always 0. For y-intercept, your x is always 0. All right. All right, so we've got here, we've got 0, 1. So 0, 1. So that tells me I've got a y-intercept. Now, what I do, y'all, with exponential especially, and usually quadratics, is because I don't know if it's a growth or decay. Well, when you first start doing this, you don't know if it's a growth or decay. You start seeing it after a while. I just kind of sketched this graph. So 0, 1 would be about here. -1, 1/2 is here. -2, 1/4. So this means it's approaching 0 and it's going upwards. So we've got a growth, right? So for this is going to be a minimum, right? For my minimum, I'm going to put approaching, so APP 0. Okay. X-intercept is going to be none because it's never going to cross that that x-axis. It's approaching 0, but it's never going to hit it. All right. So with maximum, do we have one? No. If we've got a minimum, we don't have a maximum. We don't have both. Okay? All right, so it's approaching 0, and it has a y-intercept of 1. Okay? All right, let's look at number 9. Okay. All right, so over here for my x's, I'm adding 1 each time, correct? All right, for my y's, it went from 15 to 8. All right, so I was subtracting 7. 8 to 3, I'm subtracting 5. And then I'm subtracting 3. From 0 to -1, that means I subtracted 1. From -1 to 0, okay, well, I had to add 1 there, didn't I? And from 0 to 3, I added 3. Okay? So my first difference is not constant, so it's not linear. So let's look at our second difference. -7 to -5 means I added 2. And then -5 to -3, I add 2. -3 plus 2 is -1. -1 plus 2 is 1. 1 plus 2 is 3. So we have a second difference, and that means that it's quadratic, correct? Okay, let me erase that. I don't want it right there. All right, so this is going to be a quadratic. All right. I want to draw your attention also, before we did the second difference here, if you look at the graphic, here we're adding 1, and then on the other side we were subtracting 1. Okay, so from here, this section we were subtracting, and then in this section we're adding, correct? All right, so that means that right here, when you made that change from subtracting to adding, that means that your graph made a turn. So at 0, -1, it made a turn. So let's see if it went up or down. All right, the one above it is -1, 0. So -1, 0 would be here, and then the one after it is 1, 0. So we've got a graph that's looking like that. It's going up. Okay, so that tells me a lot there. All right, so my y-intercept. We said a y-intercept, you always have a 0 for your x, all right? And 0, -1, if I look at my table, that's my y-intercept. We also graphed it just then. X-intercept. We said with x-intercept, you're going to have up to 2, and we know just by sketching that graph, we've got 2 of them, and your y's are always 0 in those, right? So if you look at your table, you have this one and this one. So these are your x-intercepts. So it's -1 and 0 and 1 and 0. All right. Maximum or minimum, when I did my sketch here, it's a minimum. So for maximum, we put none. And for minimum, that point where it turned is 0, -1. All right, you say, well, that's the y-intercept. Well, sometimes they're the same. Okay, Sometimes they're the same. But you need to be able to look to see where this changes from subtracting to adding. That is your turn point. Okay? That's your vertex, is what they call that turning point. Okay, so your vertex is where your minimum or maximum. Okay. All right. Let's look at. All right. Let's look at this one. We're adding 1 over here. All right. From 4 to 1, we were subtracting 3, and then subtracting 1, and then we added 1, then we added 3. All right. So I can tell right off that that's going to be a quadratic. And if you look at their second differences, what are they doing each time? They are adding 2. Okay, so yes, it's going to be a quadratic. All right, so I'm looking for the turn. All right, so when did it go from positive to negative? All right here, right? It went from -1 to positive, from subtracting 1 to adding 1. So right here, so this is my turn. So this is my vertex, which is my minimum or maximum. And so vertex is 0, 0. If I sketch this graph, 0, 0, and I need to plot some other points so I can see if it's turning up or down. So -1, 1, -2, 4, 1, 1, and then 2, 4. So we've got a graph going upward. So that means we have a minimum vertex of 0, 0. All right, x-intercept. X-intercept, your y is always 0, right? Well, the only thing we have on there is 0, 0. And for your y-intercept, your x is always 0. So on our table is 0, 0. And you can verify that on your graph. Your graph is crossing the x at 0 and at the y at 0. Okay, does it have a maximum? Be none, right? Okay, good. All right, let me ask you this, because you're going to need to know how to do this also. What if I said, if x is, or your input is 3, what will y be? So predict what y is going to be if your input is 3. So they're saying, okay, if you have 3 here, what is this number going to be? All right, so we can use our pattern. They're adding 2 in the second difference each time. So 3 plus 2 is positive 5, right? So that means from here to here, we're going to add 5. 4 plus 5 is 9. So y would be 9. What if I said, what if x equals -3? Y would be what? So -3 is going to be up here. Okay, so we were adding 2 each time. If I'm going backwards, you would say -3 minus 2 is -5. -5 plus 2 is -3, correct? All right, so now you've got to do this. So what minus 5 would be 4? Well, that would be 9, wouldn't it? Okay. All right, let's do, I want to do one more.
Go ahead.
Okay, well, let's just do that last linear there. Well, I'll tell you what, let's do this one. Okay, this would be number 10 on your study guide. All right, so we're adding 1 over here. So from -5 to 0, that means we had to add 5, correct? And 0 plus 3 would be 3. 3 plus 1 would be 4. And then 4 minus 1 would be 3. Okay? Looks like we got a quadratic. Let's see if our second difference is constant. We are, I am subtracting 2. And then minus 2. Minus 2. All right, so yes, it is quadratic. Our turnaround, when did we go from adding to subtracting? So we did that right here. It went from adding 1 and then to subtracting 1. So that means that this is our vertex, our turnaround is 1, 4. I don't know if it's going up or down. Okay, you can kind of look at the numbers and tell, but just to make sure, just kind of graph a little sketch of it. If my turnaround is 1, 4, so it would be about here. The next ordered pair there is 2, 3, which would be about here. Over here is 0, 3, which is here. So yeah, you've got a downward graph, don't you? Okay, so if it's going down, that means that our vertex is going to be a maximum. Okay, all right, looks like we're going to have 2 x-intercepts. So on x-intercept, we know our y's are 0, correct? So here's 1. So we got -1, 0. But I don't see the other one. Do you? No, you don't. So you know what? That means that it's going to be off the table. So this is -1, 0. So I know it's going to be over in here somewhere. So I need to really probably look right here. What would be the next number? Well, if we're adding 1 to my x's, I know that this is going to be 3 here, right? So now let's just go ahead and do what our pattern's always been doing. We subtract 2. So -1 minus 2 is -3. Okay? So then we say 3 minus 3 is 0. All right? So our other x-intercept is 3, 0. And my y-intercept, on your y-intercept, your x is always 0. So we have that here as 0, 3, which is about right. Because our vertex was at 4, so it's right underneath there. Okay, so that one was a little bit different. We had to go and find the next value there, didn't we? Okay. All right, so now remember, your homework sheet, you're only doing that front side, because the back side you'll do tomorrow night, or tomorrow in class, depending on how far we get. Okay, but that would be tomorrow's homework. The one tonight is, the front is for tonight. Virtual people, don't worry about anything I said on that, okay? Yours will be right on the Google Classroom. Yeah, and for everyone, just to verify, on Google Classroom, it'll have the right page, okay? All right. Go ahead and try those. How many problems do you have for homework? It's only 6. All right, you're good. All right, y'all have a good day.